if you have followed the previous videos, so far we have covered up the topics called band theory of solids. We have studied what are inductors, insulators, conductors, semiconductors. Then we have studied the diodes, how the p-type is formed, how the n-type material is formed. The majority charge carriers are electrons and more than the holes. The holes are greater. How the trivalent impurity is added to pure semiconductor. Pentavalent, if at all, added to the pure semiconductor. How the n-type is formed. Then what is p-n junction? Biasing the p-n junction into forward bias and reverse bias. We have studied few of the applications of the diode and the types of diodes. Then we have studied the Zener diode, especially Zener diode as a voltage regulator. We have studied the rectifiers, half-wave rectifiers, full-wave rectifiers, bridge-wave rectifiers. Then if at all the two p-n junction diode are suitably added back to back, then the new device is formed called a transistor. We have studied. That can be two types, NPN and PNP transistors. We have studied so far current components in the transistor, its configurations, common base, common collector, and common emitter. We have also seen the characteristics of the transistor. Now, today's class is all about amplifiers. Amplifiers, we will study the RC coupled amplifiers. To increase the gain, we will couple one amplifier to the another amplifier. The output of the amplifier will be given as an input to the second amplifier. There are few classes like A class, B class, AB class, C class, and so many other classes. Depends upon the specifications and the operations. So we will study all kind of amplifier classes. And at the end, we will see what is negative feedback and positive feedback. So feedback amplifiers, we will study as a third topic in this chapter. Now, before going to the RC coupled amplifier, how you will define the amplifier? The process of raising the strength of a weak signal is known as amplification. And the device which accomplishes this job is called an amplifier. So it is amplifying a weak signal into a high signal. So that process is called as an amplification, we can say that. So how it is done basically, because we have covered up the last topic as a transistor. So if you have seen the transistor, there are two sections. The input section of the transistor is always connected in forward bias, and the output section of the transistor is always connected in reverse bias. We can use this transistor into three configurations: common base, common emitter, and common collector. Normally, we use widely common emitter configuration because the current amplification factor in the case of common emitter is high compared to the common base as well as common collector. So normally we consider an NPN transistor connected in common emitter configuration. Now when I say that the input section is forward bias, it means the current is high. If I say that the current is high, it means the impedance will be low. If I say that the output section of the transistor, the current is minimum, it means the output impedance will be high. It is nothing but the low input resistance is converted into a high output resistance. So this is nothing but a basic definition of transistor, transformation of a resistor value from its low to high. So this itself says that the amplification is done because we have given the value low and it have made it into the high conversion. So this can be called as an amplifiers. So once again I am repeating, the process of raising the strength of a weak signal is known as amplification, and the device which accomplishes this job is called as an amplifier. It can be power amplifier, it can be current amplifier, it can be voltage amplifier, and so on. Here we are studying RC coupled amplifier. Okay. What are amplifiers? Amplification is the process of increasing the signal strength by increasing the amplitude of a given signal without changing its characteristics. So this we can also say that it is a faithful amplification. What is the faithful amplification? The process of rising the strength of a weak signal without any change in its general shape is known as faithful amplification. So it will not change the characteristics or the shape of the input signal at the output level. So that can be called as a faithful amplification. The input signal may be current signal, voltage signal, or a power signal. Amplifier will amplify the signal without changing its characteristics. So application of amplifier are wide range. They are mainly used in communications, controllers, audio and video instruments, etc. Because we are basically studying the transistor amplifiers, an amplifier which is completely based on transistor is basically known as transistor amplifier. Here the signals may be, the input signals may be current or voltage or power signals. Okay, and these are mainly used in audio, video instruments, communications, controllers, etc. Before we go to the multi-stage or to improve the gain at the output level, let us first understand the working principle of single stage common emitter amplifier. I've told you we'll be using NPN transistor because the flow of current is because of the majority charge carriers known as electrons. So that's the reason we use an NPN transistor, and that NPN transistor is connected in common emitter configuration because the current amplification factor here will be more. So single stage common emitter amplifier. Let's go through this. A single stage common emitter RC coupled amplifier is a simple and elementary amplifier circuit. The main purpose of this circuit is pre-amplification, that is to make weak signals to be stronger enough for the further amplification. If designed properly, this RC coupled amplifier can provide excellent signal characteristics. And this is a single stage transistor amplifier. Now you can see here in this figure, here this is the input, this is the area we gonna give an input, an AC signal between this point and the ground. Okay, these R1 and R2 are the two resistance for the proper biasing of the transistor. This is collector resistance, emitter resistance, bypass capacitor called CE. So this we say it is an RECE, a transistor, NPN transistor connected in common emitter configuration, collector resistance, and C out. This is output where we measure across these two terminals, point this and the ground terminal. So this will give an input to the transistor, to the amplifier, and here we're going to collect the output of the amplifier. I've said that the R1 and R2 are used for the transistor biasing. So what is transistor biasing? Is the process of setting a transistor DC operating voltage or current conditions to the correct level so that any AC input signal can be amplified correctly by the transistor. Or we can say that the proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal is known as transistor biasing. We can call it in that way. So that is the purpose of using R1 and R2 for the proper transistor biasing. Then the resistance R1 and R2, and we can see that the RE form the biasing and stabilization circuit. The biasing circuit must establish a proper operating point, otherwise a part of the negative half cycle of the signal may be cut off at the output. Here we have not shown properly. Actually here it should be an AC signal input. Between these 2 points there should be an input as an AC signal. So the resistance, this R1 and R2 and the RE resistance form the biasing and stabilization of the circuit. The biasing circuit must establish a proper operating point, otherwise a part of the negative half cycle of the signal. For the positive half cycle it is okay. For the negative half cycle of the signal may be cut off in the output. Okay. Here the input is Cin, the output is Cout, and the bypass capacitor is Ce. So we will study what is Cin, Cout, and Ce. Input capacitor Cin, an electrolytic capacitor Cin, which is equal or less than, we can say almost equal to 10 microfarad, this value, is used to couple the signal to the base of the transistor. You can see here. If it is not used, the signal source resistance will come across R2 and thus change the bias. The capacitor Cin allows only the signal to flow but isolates the signal source from R2. Why are we using Ce? This is called as an emitter bypass capacitor. An emitter bypass capacitor, which is almost equal to 100 microfarad, is used in parallel with Re. These two are in parallel with each other to provide a low reactance path to the amplified AC signal. If it is not used, then amplified AC signal flowing through Re will cause a voltage drop across it, thereby reducing the output voltage. I am briefing you each component why we use the resistance as well as the condensers in the circuit. Now why we use a coupling capacitor? This is called a coupling capacitor because this will couple. If we have to add up one more amplifier and we are using the cascading manner or multi-stage amplifier, then it should be coupled through this particular capacitance. So this is called as an this output should be given as an input to the one more amplifier here. Later into the next slide we will see that. So this is called as a coupling capacitor. The coupling capacitor, which is more or less, which is almost equal to 10 microfarad, couples one stage of amplification to the next stage. If it is not used, the bias condition of the next stage will be drastically changed due to the shunting effect of RC. Here you can find the RC. This is because RC will come in parallel with the upper resistance R1 of the biasing network of the next stage, thereby altering the biasing conditions of the latter. In short, the coupling capacitor CC isolates the DC of one stage from the next stage, but allows the passage of AC signal. Okay, so I have explained each component, how we have used, and if at all that components are not used, what will be the impact. If I go for the circuit explanation, once again, the capacitor Cin, you can see the capacitor Cin at the input act as a filter which is used to block the DC voltage and allow only AC voltage to the transistor. If any external DC voltage reaches the base of the transistor, it will alter the biasing conditions and affect the performance of the amplifier. We have repeated the same. R1 and R2 resistors are used for providing proper biasing to the bipolar transistor. R1 and R2 form a biasing network which provides necessary base voltage to drive the transistor into active region. Okay. The region between cutoff and saturation region is known as active region. In the case of common emitter configuration or common base configuration, we have studied the transistor characteristics in the earlier classes. And we have seen the three regions called as a cutoff region, saturation region, and active region. We have talked much onto that particular three regions for the three different configurations, transistor configurations. So the region between cutoff and saturation region is known as active region. The region where the bipolar transistor operation is completely switched off is known as cutoff region. And the region where the transistor is completely switched on is called as a saturation region. Then between the cutoff and between the cutoff region and the saturation region, we say that active region. Okay, that is fine. But what is cutoff and what is saturation? The region where the bipolar transistor operation is completely switched off, it is called cutoff. The transistor will be at its off mode, so that's the reason it is called the cut-off region. And the region where the transistor is completely switched on, it will be completely on stage. This is off stage and that is on stage. So that is called as a saturation region. And the region between the cutoff region and the saturation region of a bipolar transistor is known as active region. Why we say it as a bipolar transistor? Because the flow of current in the circuit can be because of any of the majority charge carriers. It can be holes or it can be electrons. So that's the reason we say it as a bipolar junction transistor. The resistors, you can see this again, the RC and RE. The resistors RC and RE are used to drop voltage of VCC. This is the positive voltage what we have given. Resistors RC are a collector resistor and RE is a emitter resistor. Both are selected in such a way that both should drop VCC voltage by 50%. The emitter capacitor CE and emitter resistor RE makes a negative feedback for making the circuit operation more stable. Later in next slides, we see the what is positive feedback and what are negative feedback. Then, so this I can say the explanation for this particular single stage RC amplifiers. Okay, we have studied this the same thing. Now, okay, done. So now if we have a two-stage or multi-stage transistor amplifier, here we have taken only two amplifiers cascaded or coupled one into another. So we can have the likewise we can have the multi-stage. What is the usage of having a multi-stage so that the gain at the output will be much higher? How the gain is calculated? Gain is nothing but output voltage. If you are finding out amplification for the voltage input, then the gain will be output voltage by input voltage. For the current, it will be output current by input current. So a transistor circuit containing more than one stage of amplification. More than one stage of amplification is called multi-stage transistor amplifier. You can see here, this is one amplifier and the output of this particular amplifier is given as an input to the one more transistor. So this is one more amplifier. So we have cascaded two amplifiers in this manner through the coupling capacitor Cout. So this is called coupling capacitor. So you can see in the circuit same way, this R1 and R2 and RE for the proper biasing. Okay, and we have used an NPN transistor in a common emitter configuration. This is a bypass common emitter bypass capacitor, this we can say that, and this is the coupling capacitor. The output we measure, normally output is measured between the coupling capacitor point and between the ground, and whereas instead of measuring the output across these 2 points, this output is again given as an input to one more amplifier. So this is a first stage, this is a second stage. So we can say that this is two-stage common emitter amplifier or RC coupled amplifier in a multi-stage manner. Okay, so here we use a function generator. Why we use a function generator? Because function generator is an instrument where which we can change the values of AC frequencies. Normally in India, the alternating voltage we use normal in practice from a range of 220 voltage to 240 voltage with a frequency fixed of 50 cycles per second. But if we have a function generator, here we can change the values of frequency and study the output across the final out. This one. Got it? And because we are doing this amplification for the voltage factor, so we have used an AC millivoltmeter over here. So this is one stage and this is another stage. Hope it is clear. What will be the gain? What will be the ultimate gain? The ratio of output electrically quantity to the input one of the amplifier is called the gain, isn't it? So if I say that the gain for this first stage amplifier is G1 and for the second stage amplifier is G2 and G3, G4, so on, then the total gain will be the product of all the gains. So if I say that the total gain of this particular multi-stage amplifier is in capital G, then that G should be equal to G1 into G2 into G3 and into G4. Got it? Okay. Now if you see this, how we have designed that. When an AC input signal is applied to the base of the transistor of the first stage of RC coupled amplifier from the function generator, it is then amplified across the output of the first stage. This amplified voltage is applied to the base of the next stage of the amplifier through the coupling capacitor Cout, where it is further amplified and reappears across the output of the second stage. Then, thus the successive stages amplify the signal and the overall gain is raised to the desired level according to our own applications. Much higher gain can be obtained by connecting a number of amplifier stages in succession. Now let us see, before we go into this explanation and all, let us see each component, how it is used, and then we go the operation of the RC coupled amplifier or two-stage coupled amplifier. A coupling capacitor, here you can see this one, the CC. A coupling capacitor CC is used to connect the output of the first stage to the base of the second stage and so on. So this is how we will be giving an output of this particular amplifier as an input. Again, here you got an V out 1. This is C out, this is C out 1 and C out 2 and so on. So this output is again given as an input the cascading manner in the succession manner. As the coupling from one stage to next is achieved by a coupling capacitor followed by the connection to the shunt resistor, therefore such amplifiers are called as an resistance capacitance coupled amplifier. Then why we say this as in resistance capacitance coupled amplifiers? Now here again I'm just repeating, the resistors R1 and R2 and RE form the biasing and stabilization network. Because of the negative cycle, it won't tamper to the transistor, so we need this particular 3 resistors for the proper biasing for the negative half cycle of an AC signal. The emitter bypass capacitor, this one, the emitter bypass capacitor offers low resistance path to the signal. Without them, the voltage gain of each stage would be lost. The coupling capacitor CC transmits AC signal but blocks DC. That is the role of a condenser. It blocks DC and allows the AC to pass through that. This prevents DC, therefore, this prevents direct current interference between various stages and shifting of operating point. We have studied in the last class Q operating point. So how the operation happens? See, when an AC signal is applied to the base of the first transistor, this is Q1 is first transistor, here Q2 we can see that's a second transistor. When AC signal is applied to the base of the first transistor, it appears in the amplified form across its collector load RC. The amplified signal developed across RC is given to the base of the next stage through the coupling capacitor. Here we're going to get an output, and this output is given as an input to the other base of the transistor through the coupling capacitor. The second stage does further amplification of the signal. In this way, the cascaded stages amplify the signal and the overall gain is considerably increased. According to our own application, we will increase the output. When a second stage is made to follow the first stage, the effective load resistance of the first stage is reduced due to the shunting effect of the input resistance of the second stage. This reduces the gain of the stage which is loaded by the next stage. In three-stage amplifier, the gain of the first and second stages will be reduced due to the loading effect of the next stage. However, the gain of the third stage, which has no loading effect of the subsequent stage, because third is the final one, so there will be further reduction. So I can say that in the third stage amplifier, the gain of first and second will be reduced due to the loading effect of the next stage, because we are adding to the next cascading manner next amplifier. Because of that particular loading effect, the gain will be reduced. But ultimate, if I take one more amplifier here, the third one, so the output of the third amplifier will not be reduced because there won't be any shunting effect. That is the ultimate last final amplifier. However, the gain of the third stage, which has no loading effect of subsequent stage, remains unchanged. The overall gain shall be equal to the product of the gains of three stages. As I said, if G is the total gain, then G will be equal to G1 into G2 into G3, where G1, G2, G3 are gains of the first, second, and third stage amplifier respectively. Okay, so if we plot the frequency response curve for the RC coupled amplifier, then how it happens is the voltage drops at low less than 50 Hertz and high greater than 20 kilohertz, means we'll get a frequency response constant between the range 50 Hertz to 50 kilohertz. Now what will happen? As I said that frequency response is what I said, the frequency response for the voltage gain, the voltage drops below 50 kilohertz, below 50 hertz and more than 20 kilohertz. 50 hertz if it is below and more than 20 kilohertz, the voltage will drop, but the voltage will be constant from the range 50 hertz to 20 kilohertz. So we will study for the each cases what will happen below 50 for the three different frequency ranges. What are that? At low frequency, like less than 50 hertz, as I said, the voltage will get dropped. The reactance of CC, here if you see that, the reactance of the CC is quite high, and hence very small part of signal will pass from one stage to the next stage. Moreover, CE cannot shunt the emitter resistance RE effectively because of its large reactance at low frequencies. These two factors causing a fall of voltage gain at low frequencies. Understood? Below the range of 50 kilohertz, why the voltage drops. Now, at higher than 20 kilohertz, why the voltage drops? Because we were saying that from the range of frequencies 50 hertz to 20 kilohertz, the voltage drops. The reactance CC is very small. It behaves as a short circuit. This increases the loading effect of next stage and serves to reduce the voltage gain. Moreover, at high frequency, capacitor reactance of the base emitter junction is low, which increases the base current. This reduces the current amplification factor beta. In the case of common emitter, the current amplification is beta. In the case of common base, it is alpha, and in the case of common collector, it is a gamma. Alpha, beta, gamma. Common base, common emitter, common collector. These are called as a current amplification factor. Current amplification factor is nothing but the output by input, keeping the common terminal. Whatever the output will get it, output by input will get as a current amplification factor. Due to these two reasons, the voltage gain drops off at a higher frequency, like higher than the 20 kilohertz frequency. Now, if we consider the mid frequency, from what? From the range 50 hertz to 20 kilohertz. The voltage gain of the amplifier is constant. The effect of CC in this frequency range is such as to maintain a uniform voltage gain. Thus, as the frequency increases in this range, reactance of CC, coupling capacitor, decreases, which tends to increase the gain. However, at the same time, lower reactance means higher loading of the first stage and hence lower gain. These two factors almost cancel each other, resulting a uniform gain at the mid-frequency level, and that level is less than 50 hertz to greater than 20 kilohertz. Got it? Okay, now see this. This we have explained how it is cascaded from one to another. Okay. RC couple, the resistance capacitance coupling in amplifier are most widely used to connect the output of the first stage input of the second stage and so on. This type of coupling is most popular because it is cheap and provides a constant amplification over a wide range of frequencies. See, as we have explained about the configurations, about the three different configurations. While knowing about different circuits for RC coupled amplifiers, it is important to know about transistor basics as amplifiers. The three configurations of bipolar transistors that are commonly used are common base, common emitter, and common collector. So here it should be CC, here it should be CC. Other than transistor, operational amplifiers can also be used in amplification purpose. That is not into our syllabus. We are not talking about the op-amps. We are only finding out the amplifiers with respect to transistors, not with op-amps. Common emitter configuration is commonly used in audio amplifier applications because common emitter has a gain that is positive and also greater than unity. In this configuration, emitter is connected to ground and has high input impedance. Output impedance is minimum or medium, we can say that. Most of these types of transistor amplifier applications are commonly used in radio frequency communications and optical fiber communications. This is all about common emitter. Now, common base and common collector we will see. Common base configuration has a gain less than unity. In this configuration, collector is connected to ground. We have low output impedance and high input impedance in common base configuration. What about common collector? Common collector configuration is also known as emitter follower because the input applied to the common emitter appears across the output of the common collector. In this configuration, collector is connected to the ground. It has low output impedance and a high input impedance. It has gain almost equal to the unity. Okay, so Before we go to the transistor parameters, basic parameters, I'll just explain the advantages and the disadvantages of this particular RC coupled amplifier. This is, again, I'm going back to this particular slide. This is much important. Again, I'm repeating, this is an input, AC input, okay, input condenser. Then the biasing resistance R1 and R2, and this is also responsible for biasing and stabilization. Transistor, common emitter. This arrow indicates what? It indicates the flow of current in the circuit. This is an N, P, N. All the electrons in NPN, this N region will be moving towards the base. As the electrons are moving towards the base, the direction of flow of conventional current is opposite to the electron. So this is in opposite direction. So this symbol is the symbol for NPN transistor. This is collector resistance, coupling condenser. So what are the advantages? As we are saying that to increase the gain, we are using a multi-stage amplifier, but we have few advantages and disadvantages. If we go with an advantages first, it has excellent frequency response. The gain is constant over the audio frequency range, which is the region of most important for speech, music, etc. Especially wherever we see an amplifier on the stage, when somebody is speaking onto that. So this is the best one. We use a common RC coupled amplifier. It has lower cost since it employs resistors, capacitors, which are very cheap. If you see that, this hardly transistor costs 20 rupees to 40 rupees, and this is Indian. If you go with an Indian currency, hardly 1 rupee, 2 rupee, 3 rupees, and 5 rupees. So because of the cheap cost of the electronic components, this is much. The circuit will not make the prices high. The circuit is very compact as the modern resistors and capacitors are small and extremely light. It is very compact. But there are few disadvantages even. So what are the disadvantages? The gain of an RC coupled amplifier is comparatively small because of the loading effect of the next stage. We have studied that, for every next, because of the shunting effect, the output of that particular first transistor, first amplifier will be less. Again, for the second shunting of the second amplifier, again it is making less. Ultimately, the final amplifier will have the gain more because there is no further shunting, no succession. So the disadvantages of the RC coupled amplifier, I can say that the gain of an RC coupled amplifier is comparatively small because of the loading effect of the next stage. They have the tendency to become noisy with age, particularly in moist climates. Impedance matching is poor. It is because of the output impedance of RC coupled amplifier is several hundred ohms, whereas that of a speaker is only a few ohms. Hence, little power will be transferred to the speaker. So, in that case, definitely there will be a noise and distortion. So, these were the advantages and a few disadvantages of the RC coupled amplifier. Now, see, we have studied this for the three configurations. What are the parameters? If you go with the parameters, a good amplifier must have all the following specifications. It should have high input impedance. It should have high stability. It must have high linearity. It should have a high gain and bandwidth. It must have high efficiency. This all will make a good amplifier. Bandwidth, we have studied what was the range. It was from below the range of 50 Hertz to the above range of 20 kilohertz. The voltage was dropping, but the mid range between 20 kilohertz to 50 hertz to 20 kilohertz, it was a mid range was perfect. The range of frequency that an amplifier circuit can amplify properly is known as bandwidth of that particular amplifier. The curve below represents the frequency response of single stage RC coupled amplifier. We have studied that the curve that is between the frequency and the voltage gain. If you are talking about the gain for the voltage input, then the frequency versus the voltage gain will give the frequency response curve. The curve which represents the variation of gain of an amplifier the curve which represents the variation of gain of an amplifier with frequency is called frequency response curve. The bandwidth is measured between the lower half power and upper half power points. P1 point is lower half power and P2 is upper half power respectively. A good audio amplifier must have the bandwidth from 20 to 20 kilohertz because that is the frequency range which is audible for any human being. Gain. Now let us study what is gain again. Gain of an amplifier is defined as the ratio of output power to the input power. Gain can be expressed either in decibel, if we are talking about the sound, or in numbers. Only numbers, because if I say that the voltage input is the voltage and I am finding out the gain, that is an output voltage by input voltage. Or in respect of the current, the output current by input current. It means the gain will be in numbers or in decibels. Gain represents how much an amplifier is able to amplify a signal given into it. Equation represents how, if we are taking in the power, so G will be equal to output power by input power, P out by Pin, where P out is output power and P in is input power. The equation below represents gain in decibel. If we are finding out the decibel, then gain in decibel should be equal to, in the form of logarithm, so it will be 10 log of P out by P. So that this converts into the form of decibel. Gain can also be expressed in voltage and current. Gain in voltage is ratio of output voltage to input voltage, and gain in current is the ratio of output current to the input current. We have talked about this. Equation of gain and voltage, gain in voltage and current is shown below. The same output voltage by input voltage, output current by input current for the gain in current. High input impedance. Input impedance is the impedance which is offered by an amplifier circuit when it is connected to voltage source. The transistor amplifier must have input impedance in order to prevent it from loading the input voltage source. So that is the reason for having high impedance in the amplifier. What about noise? As we have talked about the disadvantages in the noise, because there will be a little power transfer to the speaker, so definitely there will be a noise. Noise refers to unwanted fluctuations or frequencies present in a signal. It may be due to the interaction between two or more signals present in a system, component failures, design flaws, external interference, or maybe by virtue of certain components used in amplifier circuit. Linearity. Amplifier is said to be linear if there is any linear relationship between the input power and the output power. Linearity represents the flatness of the gain. Particularly, it is not possible to get 100% linearity as the amplifier uses active devices like BJT, bipolar junction transistor, JFET or MOSFET, which tends to lose gain at higher frequencies due to internal parasitic capacitance. So we cannot expect 100% linearity in any of the form. In addition to this, input DC decoupling capacitors sets a lower cutoff frequency. What about the efficiency? The efficiency of amplifier represents how an amplifier can utilize the power supply efficiently, and also measures how much power from the power supply is gainfully converted to output. Efficiency is usually expressed in percentage, and the equation for efficiency is given as P out by PS into 100, because we are talking about efficiency, so it should be into 100 percentage wise, where P out is the power output and PS is the power drawn from the power supply. A Class A transistor amplifier has 25% efficiency and provides excellent signal reproduction, but the efficiency is very low. We'll go in depth for all the classes of an amplifier. Class A, Class B, Class AB and Class C. Class C amplifier. Class C amplifier has efficiency up to 90%, but the signal reproduction is bad. Class AB stands in between Class A and Class C amplifiers, so it is commonly used in audio amplifier applications. This amplifier has efficiency up to 55%. So for each classes, the efficiency is different. Slew rate. Slew rate of an amplifier is the maximum rate of change of output per unit time. It represents how rapidly the output of an amplifier can be changed in response to change in the input. So it depends on the time. So time. What is, again I'm repeating, it is nothing but the slew rate is nothing but the maximum rate of change of output per unit time. So it means how much the output is changed with according to the time rate. So it represents how rapidly the output of an amplifier can be changed in response to the change in input. Stability. Stability is the capacity of an amplifier to resist oscillations. Usually, stability problems occurs during high frequency operations close to 20 kilohertz in case of audio amplifiers. The oscillations may be high or low of amplitude. So, what is the conclusion of an RC coupled amplifier? Amplification is a process of increasing the signal strength by increasing the amplitude of a given signal without changing its characteristics. Faithful amplification is nothing but an RC coupled amplifier is a part of a multi-stage amplifier wherein different stages of amplifiers are connected using a combination of resistors and a capacitor. An amplifier circuit is one of the basic circuits in electronics. So we have seen a single stage amplifier as well a multi-stage amplifier, which is normally known as RC coupled amplifier. So this is what all about the amplifiers. Now we have a